Now that we've been introduced to equations, we'll see that what we've been working with and will be working with for the most part will be linear equations. And linear comes from lines, so they have something to do with lines. For instance, a line never changes its angle. You notice it doesn't curve up, curve down, it goes in one direction only. So what we'll cover in this section is basic concepts, solving linear equations, applying distributive property, clearing fractions and decimals, equations with no solutions, one solution, or infinitely many solutions. Tables help us understand linear equations better, so that's why we'll have a lot of tables. So here's a problem. Suppose that a bicyclist is 5 miles from home, riding away from home at 10 miles per hour, as shown in figure 2.1. The distance between the bicyclist and home for various elapsed times, remember that means time that has passed, is shown in table 2.3. Now notice the elapsed times start at 0, but he's already gone 5 miles. But we're starting at that 5 mile point. Then after 1 hour, 2 hours, and 3 hours. Notice at 0 times 5, then at 1 hour he's at 15 miles. So he's actually gone another 10 miles, right? And then at 2 hours he's 25 miles. So he's gone another 10 miles. So it's at 10 miles an hour, looks like, is how fast he's going. And then after 3 hours he's 35 miles from home. So now let's see if we can figure out a formula for this. If you can relate this table to the other things we've done, the one about the Twitter accounts, remember it was 0.3 million a day, and then the other was snow falling. At first it fell you had 3 inches, and then after that it fell half an inch every hour. So remember what we multiplied times our x. So it was how much per day is added on. See, so this is per hour, 10 miles per hour. So that would be the number. So we have our distance, and that equals 10 times our x. But remember, we're starting off 5 miles. We're not starting at 0, we're starting at 5. So we're going to add the 5 on. So you can see that here he's already gone 5 miles, and then for every hour after that, you can stick in there, see, and then he'll go 10 miles for every one. So let's say if he goes 3 hours, then 10 times 3, he'll go 30 miles. Or 35 miles, 30 plus 5, you can see that. Now that we have the formula, we can figure out no matter how much time has elapsed. So, for instance, in a half hour, how far would he go? So, let's see. D equals 10 times 1/2. We could do 1/2, or we could do 0.5 plus 5. So that is 5 plus 5 equals 10. So we go 10 miles. He'd be 10 miles from home in a half hour. So we can use our table for at point 0, where he's 5 miles, or for 1 hour, 2 hours, or 3 hours. But what about, and so 2 hours is 25 miles, you see. But what about 18 miles from home? What if we wanted to find out from 18 miles from home, or 2.5 hours? So let's try it. Let's say if he was 18 miles from home, we put the 18 in for distance, right? Then we have the 10x plus 5. See, this is where it's going to come in handy to know how to solve these things for x. So we want to get our x alone, so let's subtract the 5. Okay, we'll subtract 5 from both sides. So we've got 18 minus 5 equals 10x plus 5 minus 5. Okay, so the left side is 13, the right side is 10x. Alright, and so now we'll divide both sides by 10. Divide by 10, divide by 10. And that gives us, here, it'll give us x equals, and on this side, 10 into 13 is 1.3. So 1.3 miles is how far he'd go, not miles, pardon me. In 1.3 hours, he would be 18 miles from home. And that's not on our table. Same with 2.5 hours. We go d equals 10x. Whoops. So we got d equals 10 times 2.5 for 2.5 hours plus 5. So 10 times 2.5 is 25 plus 5 equals 30. So in 2.5 hours he'd be 30 miles from home. Anyway, we're going to be doing more of these sort of things. So d equals 10x plus 5 is a linear equation. As a matter of fact, it's a linear equation in one variable. And there's a few features that it has. One thing is the x term. The x term. The x is not to a power, and it's not like in the denominator of something. Another is that it's, notice that 10 miles, 10 miles, 10 miles, and this is, the difference is 1, 1, 1. It's very regular. Sequence never changes on a linear equation. Another aspect that is important is a linear equation in one variable is an equation that can be written in the form ax plus b equals 0, where a and b are constants. That means they're just numbers, and a is not equal to 0. See, because if a was equal to 0, then it would just be b equals 0, which would not be a linear equation. Here are some linear equations. X equals 1, negative 5x plus 4 equals 3. If you look in this first column here, 2.5x equals 0. Written in the ax plus b equals 0 form, which is the linear equation in with one variable form, you would, on this first one, notice that 1 is subtracted from both sides, so it can equal 0, right? X minus 1 equals 0. A is 1. See, the x is assumed. You assume that x has a variable of 1, and b, which is the negative 1, negative 1. Okay, then our negative 5x plus 4 equals 3. We subtract the 3 from both sides, and then we get negative 5x plus 1 equals 0. And then the last one, 2.5x equals 0, was a 2.5x plus 0 equals 0. That's in the form. See, so you stick something in for b, and what could you stick in for b but 0, right? Without changing the formula. So let's determine whether an equation is linear. The first one here is 4x plus 5 equals 0. Well, remember we want it in this form here. Whoops, didn't mean to do that. Alright, I'm going to I plan on putting ax plus b equals 0 over here. Okay, so then we'll compare each one. We'll start with a. So 4x plus 5 equals 0. Okay, that's in the form already. The a is 4 and the b is 5. 5 equals negative 3/4 x is b. So that's the problem number b, letter b. Okay, so that's not in the form. So we have to get it in the form. So you know we want to have 0 over here. So how can we get 0 over here? Is we have to add the opposite of this. So we'll add positive 3/4 x to this. But if we did it to this side, we've got to do it to the other. So we're going to add a positive 3/4 x over here. See, what happens is we get that that equals 0. And this other side is in the form now. 3/4 x plus 5. A is 3/4 and B is 5. The next one, 4x squared plus 6 equals 0. Now you have to determine whether it's a linear equation, and it is not. That x has an exponent. So x, we assume, I haven't talked about this, but x equals x to the 1 power. They're the same thing. So it has an exponent, but we don't write it because, just like we don't put 1 in front of x. I mean, we can, but it doesn't matter. So we don't do it. So here, this is not a linear equation. Letter D, 3 divided by x plus 5 equals 0. Well, you can't have x in the denominator for it to be a linear equation, so it's not a linear equation. Alright, now we're going to try to solve a linear equation using a table. This could be interesting. Alright, we're going to put the values for x in the top, and then the 2x minus 5 in the bottom. And we're going to wait and see when they match. When they match the -7, or we can get to -7. Okay, so if we put in we'll put 2x minus 5, right? Okay, well, if you put in 3, you put in -3 minus. -3 minus 5, you get -6 minus 5, which is -11, which we have. Okay, try 2 times -2 minus 5. We get a -4 minus 5, which equals a -9. So this one's a -9. I can't write that small. The next one, -1. 2 times -1 minus 5. 2 times -1 is -2 minus 5 equals a -7. Let's go to the next one. 2 times 0 minus 5 equals 0 minus 5 equals a -5. So here we have -7. Here we have a -5. You can see where we're going here. We're dropping down, or we're going up actually by 2 each time. -9, -11, -9, -7, -5. Then you can guess -3, -1. The last one would be a +1. There, I made the table bigger. So you can see where we went. We kept going up 2, and the question is, where's the answer? Well, it's right here. Because that's where 2x minus 5 equals a -7. Okay, let's try this one. Actually, why don't you try it before I give you the answer? So pause the screencast. All right, now I'm assuming you did that. So we have x values in the top, and we have -3x plus 7. So we take the x value and we stick it in for x and see what it comes out to. And what we're looking for is this, 1. Where does it become 1? Okay, so if we stick 1 in for x, -3 times 1 plus 7 is a -3 plus 7 equals 4. We stick 2 in, -3 times 2 plus 7, -6 plus 7 equals 1. We stick 3 in, -3. negative 2. Put in 4. Negative 5. Okay, so notice the pattern. If we add a negative 3, we get to 7, we get 4. Add negative 3 again, we get 1. Negative 3 again, we get a negative 2, negative 3 again, we get a negative 5. And our answer is, when negative 3x plus 7 equals 1, is 2. When x is 2. Right here. Alright, so that was graphically. Now let's solve them symbolically, which is actually the best way to solve them. But the tables give us a good idea of what's going on. Give us a sense of how one thing changes as something else changes. And that's what linear equations are all about. Actually, most equations. All equations. So, here are the steps. Step 1, use the distributive property to clear any parentheses on each side of the equation. Combine any like terms on each side. Sometimes there are parentheses for other things too. But you follow the order of operations all the time. You do the left side with the order of operations, the right side, and of course the distributive property. Okay, step 2, use the addition property of equality. Get all the terms containing the variable on one side of the equation, all the terms on the other side of the other side of the equation. Yeah. Alright, you get the numbers on one side, you get the variables on the other. Alright, combine any like terms on each side. Then use the multiplication property of equality to isolate the variable by multiplying each side of the equation by the reciprocal of the number in front of the variable, or divide each side by that number. Your choice. And then the last step is check the solution by substituting it in the given equation. Alright, so let's do these. Actually, why don't you do the first one first? See if you can do it yourself. 10x minus 13 equals 0. Alright, now I'll do it. So 10x minus 13 equals 0. Step 1, distributive property, or combine like terms. There's no distributive property going on here, and there's no terms to combine. So we'll use the additive property. We'll add 13. That's step 2. And that'll give us, it'll cancel out this 13 on the left side. So we have 10x equals 13. Now we'll divide both sides by 10. And 10's cancel out. Or if you divide the top 10 by 10 and the bottom 10 by 10, you get 1x, or x. So x equals 13 tenths. Let's do B. 1/2 x plus 3 equals 6. Again, additive property first. We'll add 3. 1/2 x plus 3, actually we'll subtract 3. Minus 3 equals 6 minus 3. Same thing both sides. So we get 1/2 x equaling 3. Now we multiply both sides by 2, which is the reciprocal of 1/2. Reciprocal of 1/2. So we multiply this side by 2 and this side by 2. 2 times 1/2 is 2 over 1 times 1/2 equals 2 over 2, which is 1. Or you can cross cancel these two, and you get 1 times 1 is 1. So you get 1. So we have just an x here. 3 times 2 is 6. Alright, now let's substitute this back into the equation, the original equation. If we put a 6 in for the x, it's 1/2 times 6 is 3. 3 plus 3 is 6. 6 equals 6. Good. Our answer is correct. Do the last one on your own and then check it in the book. The same problems in the book. Estimating numbers of worldwide internet users. Alright, so here we have a formula. The number of internet users I equals 241x. Oh, the number of internet users I in millions during year X can be approximated by the formula I, that would be the number of internet users in the millions, right, during the year X. So X is the year. So that's the year. That's the internet users in millions. It's approximated by this formula. So I equals 241x minus 482,440. So it says where X is greater or less than 2007, estimate the year when there were 2,210 million, or 2.21 billion, internet users. So this 2,210 million internet users, it's what this is, internet users, right? See, so we know this part, we know the I. It's telling us what the I is, but it's not telling us what the X is. We have to find the X. It says estimate the year. Then the year is the X, right? So we just plug this in. We'll plug in the 2,210 in for the I. So 2,210, that's where the I goes. Then we have 241x minus 482,440. Okay, so now, I mean, this looks like a complicated problem, but really isn't. It's just asking us to plug something in. We might have to use our calculator. I mean, that would be the easiest way to do it. But we just follow the same method. I'm going to move it up. Okay, I cleaned things up there a little bit. But here it is. This is our 2,210 users, right? So we're just trying to find out what the year is, and the year is going to be our X. So we just plugged in the 2,210 into the I, in for the I, internet users. So now we want to get the X alone, so what do we have to do? Turn it off and think about it. We're going to add 482,440 to both sides. See, sometimes when you look at a thing with big numbers like this, it looks complicated and you think, oh, I can't do that, it's too hard for me. But it's exactly the same as if we were doing a simple problem where there were just little numbers like 5 equals 6x minus 2, you know? It's the same procedure. Just don't let the numbers scare you. We're going to add 482,440 to both sides. So we've got 482,440 plus 2,210 equals 241x minus 482,440 plus that same number, if I can get it to fit here. I'll put it on an angle. 482,440. Okay, so these two cancel each other out, right? They're the inverse of each other. All right, so now we've got to add these two combined like terms. That's the next thing we need to do. Okay, I did that on the calculator. 484,650 equals 241x. And of course, now we get our x alone, we've got to divide by 241. We divide both sides by 241, the x will be just x, right? So, dividing by 241. Divide by 241. So using the calculator again, we get 2010.9958. So it's a little more than 2010, right? It's in 2011. So we'll just put 2011. We'll approximate. And that equals our x. So that is the year 2011 is when they had 2,210 million internet users. Our next step is to apply the distributive property when we need to. Now remember the distributive property. When A times B plus C equals A times B plus A times C. Or in other words, when you have something like 5 times x plus 3. This equals 5 times x and plus 5 times 3. So it would be 5x plus 15. Okay, so let's solve this one. We have distribution right here. 4 times x and 4 times a negative 3. That will give us 4x minus 12 plus x equals 0. So now we are at the point where we'll combine like terms on the left. So we get 5x minus 12 equals 0. And we want to get our x term alone. So we'll have to add 12 to both sides to eliminate our constant. So 5x minus 12 plus 12 equals 0 plus 12. That gives us 5x equals 12. Then all we have to do is divide by 5. And we'll have x equaling 12 fifths.